Yeah,
Hello.
shall we start?
Shall we start?
Yeah, am I audible?
Yes, sir. You're audible.
Yeah,
Good
I was just saying, shall we start?
Yes, sir. We are starting now.
Perfect.
Good afternoon to all. As we celebrate our Golden Jubilee year, we extend our heartfelt gratitude and sincere thanks to everyone who has been part of this remarkable journey. Over the past 5 decades, NATPAC has remained committed to excellence in transportation research, planning, and policy support, contributing significantly to sustainable mobility and infrastructure development. This milestone not only reflects our achievements and growth, but also strengthens our commitment to fostering innovation, knowledge sharing, and impactful research for the future. In this special year, it gives me immense pleasure to welcome you all to the 34th talk of TransPedia Research Talk Series, organized by KSCSTE, National Transportation Planning and Research Center, NATPAC. This talk series is yet another unique venture of NATPAC, designed to explore diverse topics from cutting-edge technologies to sustainable solutions. Here, we will be featuring eminent young researchers to share their valuable insights for kindling the spirit of future research and development in transportation. Today, we have with us Dr. Nandan Dawda, Fellow, Observer Research Foundation, Mumbai, for sharing his valuable insights on the topic Harnessing Multi-Criteria Decision-Making Techniques for Policy Studies, a case of urban mobility. Now, I request Dr. Sabida N.M., Senior Scientist, to deliver the welcome address.
Thank you, Ashwati. Good afternoon, everyone. Respected Director NATPAC, distinguished guests, and all participants joining us online today, a warm welcome to all of you. It is our pleasure to welcome you all to the 34th edition of the TransPedia Research Talk Series. Since its launch in August 2023, this initiative by NATPAC has been promoting research through shared learning and providing a platform for young researchers to connect, exchange ideas, and contribute to the future of transportation. Today, we are honored to have with us our distinguished speaker, Dr. Nandan Dawda, a fellow at the Observer Research Foundation, Mumbai. Dr. Dawda specializes in public transport and data-driven urban policy and completed his PhD at SVNIT Surat. He will be sharing his valuable insights on the topic harnessing multi-criteria decision-making techniques for policy studies, a case of urban mobility. This session will explore how data-driven frameworks can help address urban mobility challenges and support sustainable planning. Following the presentation, we will have a Q&A session, and all the participants are encouraged to take part and engage in the meaningful dialogue with our speaker, either by unmuting to speak or by posting your queries in the chat box. So thank you all for joining us today. We look forward for an insightful and engaging session. So welcome you all to this session.
Thank you, ma'am, for the welcome note. Now, I would like to invite Srimati Ardhara S. Krishna, Junior Scientist, to introduce the speaker to the audience.
Good evening, everyone. Today we have Dr. Nandan Dawda, Fellow at the Observer Research Foundation, Mumbai. Dr. Nandan Dawda is a fellow and policy professional working at the intersection of urban development, mobility, climate resilience, and sustainable infrastructure. He is associated with the Urban Studies program at Observer Research Foundation, where his work focuses on future mobility systems, resilient cities, urban governance, and energy transitions. His research examines the evolving challenges of Indian cities, particularly in public transport, electric mobility, climate adaptation, and data-driven urban policy. Dr. Dawda has contributed to several policy papers, consultations, and stakeholder engagements aimed at supporting inclusive and sustainable urban transformation in India. He regularly engages with government agencies, industry stakeholders, and academic institutions to advance evidence-based policymaking. His work seeks to bridge research and practice by developing actionable frameworks for resilient and people-centric urban development. With this note, I welcome Dr. Nandan Dawda to this talk series. Thank you.
Thank you, ma'am, for the introduction. Now, I invite our distinguished speaker to deliver the talk. Over to you, sir.
Okay, am I audible?
Yes, sir. You're audible.
Yeah, so I'll just begin. First of all, thank you, KSCSTE-NATPAC, for this opportunity. And I'll try to justify my role, and I will try to give you a brief idea about the multi-criteria decision-making techniques so that it would be useful to all the audience. And I hope the audience consists of most of the academia as well as the civil society people and as well as the people maybe from government. So the entire presentation would focus majorly on how do we convert the qualitative analysis of the transport planning into quantitative analysis to substantiate it for decision making. And the case study that I will be presenting would be of urban mobility solutions, that is, the barriers and policy interventions for designing an integrated and sustainable multimodal transport systems. So this will be the flow of presentation, beginning with, of course, the basics of multi-criteria decision making, types and classifications. Also, one of the important thing which I would like to highlight in my presentation would be the fuzzy-based MCDM techniques and how they are more advanced compared to the normal techniques, and to see that how these methods can be applied on ground with a practical application, followed by the recommendation and conclusion. So beginning with the first and the foremost thing, multi-criteria decision-making techniques. So it is one of the important branch of operational research, or you could say a management science, more commonly known in the domain as a decision science tool, which are used by the policymakers for making an important decisions. For instance, if I give you an example, whether the BRTS should come to the city or maybe a metro system, or maybe if you would like to have some other example, like whether should we go for a non-motorized transport system infrastructure, or we should focus on moving people and constructing more roads. So these are the few examples, the practical examples where MCDM techniques can be used. Of course, it deals with the theory, methods, and the application of those in the practical problems. And the major thing, what makes MCDM very important, is the multi criteria or the multiple criteria. Now, any decision that we take would consist of various pros and cons. So, in order to consider all those pros and cons and come up with a solution which is optimized, the MCDM techniques are used. And commonly, these techniques are used to find the best alternative from the available alternatives or available options that a person or a society has. And if we talk from a theoretical perspective, then MCDM basically follows two major schools, the European school and the American school. Both varies based on their application and the way they deal with the problems. Now, commonly, if we see MCDM techniques that we come across in an academia, is either multi-objective decision making or multi-attribute decision making techniques. The MODM problem is generally the simplest form of linear programming problem that we might have studied in our bachelor's or master's. So MODM problem is generally if you have a subjective function, you have a function which needs to be optimized, either minimization or maximization, and which is subjected to some constraints. And how do we optimize your constraints so that you get either the minimum or the maximum output of our ultimate goal? So that is generally an MODM problem. But MADM problem, multi-attribute decision making problems, are dealing with the criteria and alternatives, which we shall study in the further slides. So if I just explain MODM problem, how does it looks like, then you have an objective function which needs to be minimized or maximized, and you have n number of constraints. Now this is one of the example where we want to minimize the losses subject to the constraints. So generally MODM problems look something in this way in the mathematical terms. While if I say about MADM problem, the multi-attribute decision making problem generally consists of four major things. Number one, that is the criteria. Number two, that is the alternatives. Number 3, the weightages of the criteria. And finally, we have to measure the performance of the alternative across the attribute. Let me try to explain this with a simple example. Suppose a government wants to decide whether a city should have a BRTA system, that's an alternative 1, city transport system, that's an alternative 2, and maybe a metro system, that's an alternative 3. So these are the 3 alternatives, and we want to obtain which would be the best alternative. Now these alternatives are always subject to the constraints. For our example, for the selection of a public transport mode, the criteria could be the cost, the other criteria could be the coverage, the other criteria could be maybe the trip length patterns. So those will be the criteria. And now what are the importance of these criteria are measured through the weights. And finally, while performing the MCDM methods or applying those tools and techniques, we come across an example about which alternative is the best among the given examples. So this is a typical outline or a structure of MCDM problem. Going a bit on the theoretical side, how do we solve the MODM problem, that is objective function subject to constraints? Then we have traditional optimization techniques where we might have come across linear programming problems. And of course, we have advanced optimization techniques, which are generally nature-based optimization technique as one of the forms, like genetic algorithm, particle swarm optimization, etc. And based on the type of problem and the ultimate outcome that we want, the optimization tool or technique, it needs to be decided. But if I talk about the MADM problem, then as explained in previous slides, a MADM problem generally consists of either you want to evaluate, prioritize, or select something based on the available attributes, which are either multiple and they are conflicting in nature. So this is how the entire example of the MADM problem is done. The 4 major steps that we carry out for MADM is: number 1, setting up of goal. If I connect it with the previous example, the ultimate goal is to select appropriate public transport system for the city. Now this problem has an objective. Now these objective could be the system is sustainable in nature, or maybe a system is more cost efficient. So those are the objectives. Now for attaining this objective, we need to prioritize or finalize the criteria and the alternatives. And the 2 major places where we use MADM is: number 1, to obtain the weights of the criteria, and number 2 is mapping how each alternative will help us to overcome the, which is called prioritization of, or prioritizing the alternatives. Classification of MADM problems: there are different tools, techniques, and methods, and this field is such that it is evolving day by day. There are a number of methods which are evolving based on the easiness of a person and how it becomes easy for a government to make a decision. So broadly speaking, MADM problem can be data type, based on the data type, whether the selection or the alternative prioritization, it needs to be done either using a stochastic, deterministic, or fuzzy data. Number 2 is based on the methodology. So here comes the important point, that is these methods are actually derived or are subject to the weightages, and these weights are obtained either by the expert stakeholder consultations or maybe using the optimization problem. These weights could be derived. So based on that subject, if the problem is subjective weighting, method is adopted, that AHP, ANP, and best worst methods. There are a number of methods. These are the methods just for the sake of showcasing I have added. There are more methods which are there in each of these categories. The objective weighing methods are Topsis, Mora, which are commonly used, and evaluation methods. Now here, this evaluation MADM methods are the one which finds out the interrelationship between the criteria or into the alternatives, and finally outranking methods which are derived from the European school, which eliminates the most least feasible solution and finally gives you the best solution. And lastly, based on the decision makers, the entire MADM problem can be done either using a single decision making method, or you have a group of people from whom you obtain their perception and derive the weightages. So this was the broad classification of MADM problem. And now if we want to structure the entire MADM, if you want to structure a problem using an MADM methods, then this is the flowchart. Beginning with first, that is setting up of goal, identifying the set of alternatives, and etc. So we will try to understand each of them during the example which I'll showcase in the further slides. And now coming to the second part. So generally MADM problems are widely used, and these methods are very well accepted worldwide for prioritizing of the policy interventions, or maybe prioritizing the systems, or maybe even in the field of construction management, geotechnical engineering, various places these methods are used. But now if I talk specifically for the transport planning, in transport planning, the MADM methods has one of the major issue, that is these weightages or the outcomes are derived based on human perceptions. And once the human perceptions comes into the picture, there is always fuzziness in it. For instance, if I give you a simple example, how do we obtain the weightages in MADM method is using a Likert scale. Say for example, one of the criteria is what is the importance of cost of a given system to finalize the best public transport in a city. Now for this question we ask the experts to rate the importance using a fuzzy scale that is either ranging from 1 to 5, 1 to 7, or 1 to 9, where 1 would be very low importance and maybe 5 would be very high importance. And we ask the expert to give one value to each of these questions. But now what happens here is, very low doesn't mean same for all the experts. For instance, if you have an X person, for him very low might not be always 1, but it might maybe 0.78 or maybe 0.5. And the same apply while if there is someone who is not conservative, for him a very low at the scale of 1 to 5 might also be 1.5. So in order to measure such fuzziness in the decision making, the fuzzy theory are used in our day-to-day life for the MADM problem, so that whatever outcome has been derived is more accurate, reliable, and robust in nature. Giving you a very simple example about what fuzzy actually looks like, or fuzzy scale looks like. The normal scale or the ordinal data is generally either nominal data. Ordinal data is generally yes or no, or maybe true or false. So you have either 0 or 1. And if I talk from a Likert scale perspective, then either you could have 1, 2, 3, 4, or 5 if you are using a 5-pointer scale. But what if someone's perception is 2.3? Or what if someone's perception is 4.5? So those perceptions are not measured in a traditional scale. In those cases, we have to go for the fuzzy scale. So if I talk from a fuzzy perspective, then this fuzziness of a human behavior might have been associated to various linguistic terms, like maybe, may not be, absolute, partial, etc. If you use a normal ordinal scale that is yes or no, then these parameters or these linguistic terminologies wouldn't have been integrated. And this gives us the basis to say that fuzzy theory usage in MADM problems gives more of a reliable result. Explaining you a simple example of crisp logic and fuzzy logic. So what makes fuzzy different from crisp is that you have a membership function associated with each of the Likert scale values. In full membership function, yes always means 1, no always means 0. But in fuzzy scale, it's not necessary that you have a entire value, you have only a unique value of 1 for yes and unique value of 0 for no. That might be, there might be a range of 0 to 0.5 might be yes, might be no, and 0.5 to 1 might be yes. So these are the difference of the fuzzy and crisp logic, which we will explain, which we will be understanding in the further slides. And generally, if I say about the crisp set, then crisp set is now talking exclusively from the transport planning perspective, where you have a expert opinion based outcome. If we say, then crisp sets are nothing but a Likert scale, which can vary from 1 to 5, 1 to 7, and 1 to 9. And now these Likert scale are always associated with some linguistic terminologies based on the question that you are, would be very low to very high, very important to not at all important, etc. But when we have the same thing on the fuzzy set, then each of your linguistic term, which is represented by a value, Likert scale value, would have a membership function. And these membership functions basically incorporates the ambiguity or the uncertainty of humans' behavior in your calculation. Giving you a practical example, if you are using a linguistic terminology varying from not important to extremely important, the associated Likert scale would be 1, 2, 3, 4, and 5. But now the same case, if you are doing the survey, you are getting the expert opinion, and if you are not using a Likert scale, and if you are using a fuzzy scale, then fuzzy scale looks something like this. So what happens is that each of your linguistic variable would have a range of value, and these value will be associated with some membership function. And how to develop this scale, what are the steps to be done, I'll be explaining in further slide. But the simple thing is that fuzzy set or fuzzy scale would have more variability to your linguistic term, while the crisp set or the crisp scale has only single value associated with the linguistic terms. And this is where the fuzzy and crisp scales are different, and more advanced would be using the fuzzy scale. One of the application that I'm going to explain today is the Delphi technique. How I use the Delphi method, which is one of the tool and technique for attaining the consensus among all the experts, and how these methods will give you more reliable result, that I'll try to explain. So brief introduction about Delphi technique. Delphi method is a very old method established in 1950s, and it is of course derived from a Greek name Delphi, where what we try to do is we try to get the responses or we get the answers for our question from the experts, and after obtaining all the responses from the expert in round one, we try to derive a common consensus. And using those common consensus, we come up with the final outcome about which solution is best and which solution needs to be adopted. It was established by founding member of Rand Corporation, and this is regarded as a exploratory and a detailed procedure method, both in nature, which I'll explain in the slides when I'll give you the practical example from the transport planning perspective. And these are of course the steps that we need to follow for the Delphi technique. And of course, this is a very tedious process. Delphi, if you go for any MADM problem, it involves multiple stakeholder consultation. You have rounds of conversation with those stakeholder consultation. You have to do the basic calculation and then come out with a common consensus. These are the difference between the Delphi technique and the fuzzy scale based Delphi technique. The only advantage that you have in a fuzzy Delphi method is that you don't need to do number of repetitions or the number of rounds of surveys. Within 2 surveys, you can get the final outcome. But if I talk about the traditional Delphi method, then whatever your outcome is, the first and foremost step is you do the round one. you get the responses of people using the Likert scale, then you yourself prioritize or optimize which are the top 5 and top 10 solutions. Then you go back to the experts and say, okay, this is the overall view of all the experts together. Would you like to change your opinion? And based on this permutation and combination, finally you come to the consensus where all the experts agree and believe to be at the one place. But now, as I told, that this is a repetitive process. It might happen that few of the experts do not deny to the solutions that you offer, and then it becomes very tedious process for the researchers to overcome the limitations. So now coming to the practical example about how do we use the MADM methods for transport planning and management using fuzzy Delphi method. So the MADM method which I am explaining is the Delphi method, and the technique that I am using, the scale which I am using is the fuzzy scale, and that's why it is coined as fuzzy Delphi method. So explaining you very brief about it, what was the practical example that I'm going to explain now is that what are the barriers and challenges because of which integrated multimodal transport systems are not developed in Indian cities. What are those major hurdles? And I wanted to prioritize those hurdles in a very mathematical formulation so that the results become generic and can be universally acceptable across the Indian cities. Explaining or beginning with a very brief how this problem came into the existence. So for that, first of all, let us understand what is the way our Indian cities have evolved. So initially, any city is developed. The first and foremost thing from a transport perspective is that the road network comes into the picture. Now, because of this road network and the concentrations of job within the centers, the arterial roads needs to be constructed. And now, since as there has been rapid urbanization taking place since the beginning of 1981 to 2011, there was an induced unplanned and ungrowth on the arterial roads, because of which, complemented by the urbanization, because of which, in order to fulfill the necessity of transport demand, the ring roads are developed into the city. These ring roads again cause an induced demand which attracts more people to the city, and as a result of which one more ring road is constructed. And this is a typical typology about how the Indian cities are evolved, especially the cities which has radial ring pattern in their city structure or city form. And what happened is that after all these thing has happened, or after evolution of cities in this way, later on government realized that we need to prioritize the sustainable transport solutions. So after introduction of NUTP 2005, government came into the role and they started developing the city bus routes, BRTS, and maybe the metro rail systems. So this is a graphical representation of most of the cities in India. And what actually happened during this period is people were highly dependent on the private modes of transport. And all of a sudden, if you provide them a public transport and tell them to switch from your main private mode to the public mode, people would definitely not switch. And here comes the basic question, that one of the potential reasons why they do not switch to public transport is that the city doesn't have an integrated multimodal transport system in picture in a given city. So this was basically a theoretical brief about what was the problem and why I selected this research question. Beginning with the entire process, how this entire analysis was carried out. So ultimate aim was to prioritize the barriers affecting integrated and multimodal transport design in Indian cities. So first and foremost step, what I did was obtaining the barriers identified from the literature review, and those literature review was carried out using the systematic literature review method, where we could get the exact barriers which are actually influencing the Indian condition. Once those barriers were identified, now I wanted to prioritize. Based on literature, it might happen that I would have got 50 or 60 barriers. And it's not possible to solve all those 50 or 60 barriers. So I wanted a list of barriers which are the most or at most important for the Indian cities. And for that, I adopted the fuzzy Delphi method. So after obtaining the barriers from the literature review, I started with a Delphi technique, where in Delphi technique, I had to carry out the user perception survey, that is the stakeholder survey of the experts. One of the important thing that needs to be remembered over here is that in all the MADM problems, your expert are the utmost importance. So it is very critical to finalize or select your expert which are actually contributing to the field of transport planning. This is not a simple survey that we do for the users, but this is for the high-end stakeholder, policymakers, government authorities, and admin people who are involved in shaping the future of urban transport in India. So the experts were selected, and then I carried out the surveys. And in this survey, one of the important things, since I was using the fuzzy perception scale, so it becomes very important to develop that scale based on the opinion of my experts. So first and foremost, in round one, I just briefed them about the barriers which I've identified from literature review, and I asked their perception about the linguistic terminologies, maybe from not important to very important, or maybe very high to very low, at the scale of 0 to 1, which I'll explain again in the further slide. So in the first round of Delphi survey, the fuzzy perception scale was developed, and the barriers which I've identified from the literature review was proposed to them. After that, the clubbing of all the perception of experts was made, and a common perception scale which is representative of all the experts was developed. And in the second round, the experts were asked to rate the importance of these barriers at the scale using the fuzzy perception scale that we have developed. That was the fuzzy Delphi round 2. After that, there are various methods established in the literature about the threshold. So those thresholds were measured, and finally, whether to stop or move ahead was decided, and the significant barriers were identified. Brief about the literature, systematic literature review. 5 major steps were carried out, beginning with material collection and refinement, descriptive study, selection of categories, categorical analysis, and list of identified barriers. This is a very established tool of SLR given by Roussel et al. And of course various other authors in the past. So that can be obtained anywhere from internet. So those systematic literature review was carried out. The protocol or the review protocol that I had considered while obtaining the barriers are keywords such as barriers to multimodal transport, sustainable transport, integrated transport systems, integrated multimodal transport systems. And the Boolean operators were and or, both were used. Initially, the search was made only in the title, abstract, and keyword, and based on which the total number of articles were obtained. And the time window, of course, it's a very old study. I completed my PhD in 2023, but the literature review was in 2020. So till 2020, this time window was selected. And other important criteria was the database. The focus of most of the researchers in the maybe traffic engineering or other domain might keep them restricted to Scopus database. But when we are dealing with the transportation planning problem, it's necessary that we have to even include various reports and maybe various other publications which are not SCI index journals, but still they are at the importance at a very much importance. Maybe some reports from WRI or GIZ or maybe our Observer Research Foundation. So those reports are also very crucial when you carry out the study in the domain of transportation planning, because transportation planning doesn't deal with a traditional issue that is maybe an optimization of traffic or maybe something else. This is more which deals with the humans and the government, and the think tank society or the civil society are at the utmost importance when we are dealing with the transportation planning. So based on literature review, there were a number of barriers which I had identified, and in all 32 barriers were identified by me, among which, explaining a very simple one, pro mobility established powers and tradition, which means that decision to select or decision for any transport system in cities are governed by the political will. So that was the meaning of this barrier. So all such barriers were identified and were tried to be translated in a simple words. The other one is maybe lack of integrated land use and planning is one of the important barrier why multimodal transport cannot be executed. Lack of legal backing for NUTP. NUTP is a policy. It just acts as a guideline, but whether to mandate it or not is an important or critical issues. Then maybe lack of public transport modes in city, since the study was not restricted only to the metro cities. So this come out as a one of the important barrier, because if you look to the tier 2 cities or tier 3 cities, over there still only paratransit acts as a main mode of transport. Lack of experts in the domain of urban transport, as we all know that the entire transport function needs to have a dedicated cadre or needs to have some transport planner which are officially involved at the ULB levels. Presently, if we look, then IAS is the one who takes after all these aspects. So then absence of footpaths, cycleways, lack of transit fleet size. So all those barriers were obtained based on literature review. And at the end of literature review, I came with a list of 32 barriers. Now, these 32 barriers might not always be the best list of the barriers. I need to prioritize maybe 20, 10, 15 barriers which are the utmost importance. And once I get those barriers, then I could come up with a solution or the policy intervention to solve these barriers. So this was a list of barriers. Looking to the list of experts for the Fuzzy Delphi survey, 16 experts were taken during my research. Now, these experts, well, as I told, list of experts becomes a very crucial step while carrying out the MADM tools. The list consisted of policymakers, consultants, academia, as well as people from the civil society. Minimum 15 years of experience was the criteria for selecting those experts, and also care was taken that all these experts deliver their individual opinion, so that all the ambiguity and the different perceptions from each of these experts could be carried out. So as I told in first round, I just showcased them the list of barriers, and few of the recommendation that came from this consultation was: number one, to reframe for more clarity. For instance, I had coined a barrier as establishment of enforcement of public space by hawkers, but it was renamed as lack of street vending policy. The another barrier was high dependency of city dwellers on private mode. The suggestion came was social and cultural sentiments and stigma towards certain modes of transport. And there were many barriers which were proposed to be merged for the better clarity. For instance, the barrier which I had proposed was presence of multiple public transport operator and resistance of public transport operator to integrate service. These both barriers were merged and the new barrier was coined, that is lack of policy measures to enforce operation of illegal cleanside operations. So these were few renaming, reshaping of the barrier happened, and there were many barriers which came from the experts, which were missing in my list based on the literature review. So all these barriers were again modified, and again finally at the end of first round of Delphi survey, 32 barriers were identified. Also, one of the important thing what happened over here is that these barriers were also classified into 6 different categories for the better clarity. So this was the outcome of my first round of Delphi survey. Now coming to the most important part, how do we execute the fuzzy Delphi survey? So for fuzzy Delphi survey, as I told, we are using a fuzzy perception scale. So the first and foremost step is to develop a fuzzy perception scale. which represents the behavior or the opinion of all the experts. So how I did is, this is the diagram which I shared with the experts. I told them that the linguistic terminology varies from not important to extremely important for all the questions that I'll be proposing. And I want you to tell me, okay, if you have a scale of 0 to 1, what are your threshold for the terminology not important? So A and B. Now again, this is, and what this trapezoidal and triangular shows the membership functions. So membership functions is used from a transportation perspective to capture the variability in the behavior of the experts. So this image was shared with the experts and they were asked to give the values for this A to M alphabets and how do they perceive each of these variables. So since I had 16 experts, 15 experts, those 15 values of A to M were obtained to me. The next critical step was to how do I develop a common fuzzy scale, because the stakeholders are going to be same for the entire exercise. So I need to have a common fuzzy scale, and for that, in this, for instance, this is the outcome which I obtained. Okay, for instance, expert like XYZ, for them not important might be 0.1. The A value, A and B value for not important was zero point 0.1 and zero point 0.3. But there were few experts for whom not important was 0 to zero point 0.1. There were few experts like Sujata Saman where value was 0.05 to zero point 0.1. So there was variability on how individual perceives the linguistic terminology. And the ultimate aim of using fuzzy scale was to capture this ambiguity or to capture these individual behavior of all the experts. Same applied for the slightly importance. The value varied from C to E, which if C, D, and E, three values I wanted because I had used triangular membership function. So for this, for a few experts, it varied from 0.18 to zero point 0.4. But it was possible that for few experts, it began itself with 0.3 and ended in 0.4. So all these ambiguities of human behavior or the human perception was captured by getting the value from A to M. The next step was how do I make a common scale, common fuzzy perception scale, which represents the behavior of all my experts. So for this, I carried out the method proposed by Gulari et al., which talks about the aggregation of fuzzy number, where it was very simple. Number one, that the A value over here will be nothing but the average of all the experts. And the B value, in order to capture the maximum ambiguity, B value will always be the maximum value of B given by all the experts. This was for the trapezoidal function. But when we come to the triangular function, the C value, that is the first upper half of the triangular function, will be the minimum of all the given values. D would be the average and A would be the maximum. The logic behind using this method of Gulari et al. Is that maximum ambiguity or maximum variation of human behaviors are captured over here. And then when I went for the round 2 survey, the experts were only told to say that this is experts were only requested that this is the ultimate or the final fuzzy perception scale which I have obtained. Now tell us, okay, for you barrier B1 is how much important, and the behavior, their perception was measured in linguistic terms and not in terms of these values. Only these linguistic terms were proposed, but before that it was made them clear that this scale is the one which I'll be using for my entire analysis. And then finally, what we need to do is that the behavior has been obtained in fuzzy scale. So if someone has stated slightly important, then slightly important will mean 0.1, 0.3, and 0.5. But I need to convert this fuzzy scale now again to a given number or a single value. And for that, we go for a step called defuzzification of data. And defuzzification has various methods that established across the given passage of time. But what I did was simple center of gravity method for differentiation was adopted, where what you do is just average the values. Average the value of C, D, and E, A, B, etc. And then finally I got a table which would be having the fuzzy values or the fuzzy perception for the barriers which each of the experts has stated. So here I've tried to show using this screenshot, but I hope it's visible. So over here you could see I have expert 1 to 14, and here are my barriers B1 to B32. And suppose expert 1 has told these barriers is very important. So for me, very important was 0. 0.7, 0.95, 1 and 1. So this value has been showcased over here. So now I have perception of 14 experts for all 32 barriers. So then comes the last step where I need to find out the threshold and I need to derive the experts agreement on each of the evaluated items. So for this, threshold value is obtained using the distance formula, which you could obtain in any of the fuzzy theory methods. And this distance was measured to be less than 0.01. And based on that, the barrier selections were made. So in explaining in a practical terms, if you have 14 experts, you have to first average all the values of A, B, C, and D. And once you have this average value and you have the individual value, you have to obtain the distance from the individual value, average value to the individual value, and you have to measure what is the distance that you derive. And suppose this distance is obtained to be less than 0.01, that means all are having the consensus. And suppose if this distance is more than 0.01, that means consensus has not been reached. So based on this, the distance for each of the experts for all the barriers were obtained. And finally, the second thing what I did was experts agreement. So among these 14 experts, there were only only one expert whose distance was greater than 0.01. So if I say the degree of consensus I have is 13 divided by 14, which is around 92%. So if the experts agreement was greater than 75% for the barrier, that barrier was adopted and the remaining barrier was eliminated. And this is the final calculation for all the barriers, 32 barriers. Their weightage is obtained by defuzzification, percentage of consensus, and whether I have selected or rejected. So up till 75% I had selected. The consensus where it was not 75%, all were rejected. And finally, from the list of 32 barriers, I got a list of 21 barriers, which are at most important for my study and to carry out the further analysis. And last thing that was done is for these barriers, I asked the experts to group them or club them for the better clarity. And what final outcome I derived was the barrier for designing an integrated multimodal and sustainable transport solutions could be classified into 5 major categories. Number 1 is spatial mobility and planning barriers. Number 2 is policy, regulatory, and institutional barriers. Number 3 was city level barriers. Number 4 was operational and infrastructure barriers. And number 5 was information and fair integration barriers. And based on the common consensus obtained from these experts, this classification was made. Simply showcasing you these barriers. I hope we have 5 minutes more, right? Can anybody please tell me?
Yes, sir.
Perfect. So looking to these barriers, the first and foremost, partial and mobility planning barriers were number 1, inadequate demand management strategies. Cities always focus from the perspective of supplying more to the supply. Government always focus from the supply side, but there are very few demand management strategies which definitely needs to be adopted for ensuring integrated multimodal transport system. Pro mobility established powers and tradition, which I explained. Absence of uniformity in specification of rolling stock and allied infrastructure. Number of types of buses are there. No common. You have urban bus classification. Still, OEMs come up with some different structures. There are no common guideline which is available. Then strong emphasis on construction of mega projects instead of improving or optimizing existing service. If we look to the data of buses per capita in most of the cities or buses per lakh population as an indicator, most of the cities are below the benchmark. And still, if you go to the cities, they might have a metro system. For example, Lucknow, or maybe Nagpur, or maybe Jaipur. So this barrier was more to focus that let's first improve the existing services and then switch towards the metro services. Lack of know-how planning of urban transport system. Of course, most of us would have come across. There are silly things that happens and no focus has been done for designing and sustainable urban transport planning solutions. One of the example is, of course, the monorail in Mumbai, where they have just constructed the one stretch which goes for maybe 7 kilometers without any integration with any other modes of transport. Limited integration between academia and planning authorities, lack of stakeholder participation, and of course, lack of integrated land use and transport planning. The master plan never speaks with the comprehensive mobility plan. Giving a very simple example for Surat, the master plan had different projects, while comprehensive mobility plan had a very different project from the transport perspective, and they do not talk with each other. So these were the major barriers from spatial and mobility planning. Policy, regulatory, and institutional barriers, lack of holistic approach in developing laws and regulation, absence of UMTA. Even if the UMTA has been established, whether they are operational or not, it's a big question. And if even they are operational, whether they do have power to take decisions or not, it's again a big question. High fragmented system with no interaction mechanism. As I told, plans are made independently. No, there is no talk that happens between a planner and a transport engineer, or a transport planner and the urban planner in the city. And of course, there is no interaction mechanism also established. Lack of financial assistance for development of transit system. Cities, most of them struggle for getting the buses. Of course, after this was a very old study. Recently, after PM EZAP Yojana and various other steps, the inclination has established towards the e-bus services. But still, it is one of the major constraints. Low tax incentives or subsidy to transport infrastructure. And finally, poor mechanism to evaluate the performance of existing transit system. We do not have a proper KPIs. We do have KPIs which but doesn't focus or showcase the reality of a society or from a consumer perspective. Vehicle kilometer can be an KPI for the public transport, but whether it is solving the issue from the user's perspective is something which is missing. City level barriers, political instability, one of the common thing that we have observed. The political will changes, the entire project goes away. That it goes away. Lack of varied public modes of transport. We might have different modes in different cities, but there is no proper systematic framework or planning about when which mode of transport needs to be established or developed in the city. Increased travel demand due to urban sprawl, huge urbanization happening, people switching towards or shifting towards the cities, and people are moving far away from the cities, which definitely increases the travel demand, but also cause a major issue of the sustainable transport systems. If they are coming traveling by the private mode, it's a biggest concern for the society. Social, cultural, and sentiments towards certain modes. For instance, habit, what we say, okay, people do not want to switch to the other modes. High dependency on informal and organized like paratransit, and lack of awareness among citizens about the benefits of multimodal transport system. Physical integration barriers were lack of space itself. What we do is the retrofitting. We do not have a greenfield project. We have a brownfield project. And hence the city doesn't have space itself to capture or to retrofit the multimodal transport systems into the existence. Lack of NMT facility. The best example for these spaces is if you look to the all new metro systems that are developed, they have park and ride facilities, but they do not have sorry they have just drop off facilities and no parking facilities. So if you want a person to park his vehicle at metro station and go to the metro and then come back, that's not possible in most of the cases. NMT facility always a big issue in India. Priority and vision for accessible infrastructure, very obvious, everyone would agree it's lacking. And lack of state vending policies. Operational integration barrier, demand management surveillance system was absent of policy to enforce the operations of paratransit. And maybe if I give a simple example, in cities like Mumbai, these auto rickshaws are making the transport system more chaotic, and they demand any amount of money for the first and last mile connectivity. And best of the example for this is people traveling from Bandra or Kulla to BKC, which is a classic example. Inadequate transit fleet size, and finally, inadequate capacity and capability of local public transport authority to operate and manage PT services. We have four different models for PT operations. That could be STUs are operating, or maybe SPVs established, but still most of them lack the basic understanding. And coming to the information and fair integration barrier, these are the standard barriers that we always face, like common guideline, single fare policy, ITS infrastructure, and common fare collection system. So based on this, the second part of my study was to prioritize the policy interventions. And again, using MADM framework, I had showcased how each of these policies will overcome your barrier. But over here, showcasing a very general recommendation for the study, what needs to be done. A simple step: lack of holistic approach for developing laws and regulation. Comprehensive Urban Transport Act needs to be established. We need to mandate UMTA, and we need to give financial freedom to the UMTA to take the steps or to take the decision. Then only the things would definitely change. The best controversy that recently was going was with the tunnel project and the establishment of metro systems. So in Bangalore, so that is one of the important case study that I was studying, and there are various other recommendations which were proposed. Finally, concluding, the political will, legal support is something is lacking in order to ensure the sustainable multimodal transport system in Indian cities. Until and unless that is not happening, it will become a very difficult situation for Indian cities to switch or move towards an world-class multimodal transport system in Indian cities. And there are various other recommendations. I'll share the paper where you could find all these barriers explained in more detail. And finally, I'd like to end the presentation by saying that the test of civilization is in the way that it takes care for its helpless members. So this is all a very brief idea about both the tools and techniques and the practical problems from the transport planning based on one of the part of my dissertation. I would again like to thank NetPack for this opportunity, and I hope this would have added value to the conversation. Yeah, over to the organizer.
That was a nice presentation. Thank you, sir. Now the forum is open for discussion.
No questions, huh?
Sir, I have a question, actually, Corey. You conducted this survey. The experts are from all over India, right? From Calicut to different places. They are from. So they will be evaluating based on their interpretation or the what is happening in their area. Isn't it this transportation planning that is highly specific, locally specific to that particular location? So is that affect this method by using this experts from various areas rather than using a particular concentrating a particular area?
See, the ultimate aim of the study was to carry out the macroscopic analysis and not the microscopic analysis. So the thing was that the study aimed to showcase the condition across Indian cities, not specific to one or single city, and in order to capture all the variability which do exist at the micro level. and hence the experts were selected across the different geographical locations. And as I told, one of the important steps that we took care about was the expertise should be greater than 15 years. So even it might be possible, if you look to a consultant, he might have worked for few years in Bangalore and few years in Mumbai. So, all those things were taken into consideration by selecting the experts. I hope this is what this question, this is only what you asked, right?
Yeah. Yes. Thank you for that.
Yeah, yeah.
Okay. Any other questions?
I'm sorry, I was at home, so I didn't thought of to switch on my camera. But yeah, any questions? Would be happy, or maybe we could discuss on the after the lecture also. Please feel free to reach out.
I think there is no questions. Shall we wind up this session?
Yeah.
Okay, thank you, sir. Now I request Dr. Anila Cyril, scientist, to propose the vote of thanks.
Good evening, everyone. It is my privilege to propose the vote of thanks on behalf of the NATPAC family and the organizing team of the TransPedia Research Talk series. We are grateful to Dr. Nandan Dawda, Fellow, Observer Research Foundation, for delivering such an insightful talk on harnessing multi-criteria decision-making techniques for policy studies, a case of urban mobility. Thank you, Dr. Dawda, for sharing your research experience and practical insights on urban mobility and policy studies. Your presentation helped us understand how scientific decision-making tools can support better transportation planning and policy making. The examples and case studies you shared made the session more informative and engaging. As NATPAC celebrates its Golden Jubilee year, we are happy to host experts and researchers like you through the Research Talk series. Such interactions strengthen our commitment to promoting research, innovation, and knowledge sharing in the transportation sector. I would also like to thank all the participants who has joined us today. We are especially thankful to our director, Dr. Ashalada R, for her encouragement and support in organizing programs like this. My sincere appreciation also goes to the organizing team and everyone who worked behind the scenes. Once again, thank you, Dr. Davda, for your valuable contribution and for spending your time with us today. We look forward to many more such enriching sessions in the future. Thank you all and have a wonderful evening. Thank you.
Thank you. Thank you very much.
Thank you, sir. We are now closing the session. Thank you.
Thanks.